Alright, you're going to measure 300 milliliters of the 12 millimeter size beads into a larger beaker. Then you're going to pour them into the plastic tube. Alright, putting the plastic tube back up. I have 200 milliliters of water in, or 100 each, in the graduated cylinders. What you're going to do is have a few of your friends. You got 3 stopwatch people. They're going to be timing how long it takes the water. Once the water person pours the water into the tube, once it hits the top of the beads, they're going to start the stopwatch. Once it hits the bottom of the beads, they're going to stop it. So that is our wetting front time. So they're going to take 3 of those measurements, 3 people, all right, and what we're going to do is we're going to average out their measurements, how long it takes the water to move through the beads. It's your permeability. Okay, here we go. Stopwatch people, ready? Okay, they're going to figure out our math. Meanwhile, I'm going to keep pouring. So that's part is our permeability, the rate of. We're going to see how much water it takes to fill up the pores. So that's going to be our porosity part of the permeability porosity. Okay, we want to make sure there's no pores that are not filled. We want to make sure that none of the plastic beads are floating. All right, once we have that measurement, I'm going to come back with all the measurements for you. Everything's going to be written down by your recorder. Then we got to get the water back. So empty the extra water out of the graduated cylinder. And I'll move this up. So now we have the rate at which we did our average, where that's our permeability. The amount of water in the tube compared to the total volume of the beads is going to be our porosity. Now we got to look for our water retained. So that means I got to let the water flow out and then do your favorite thing, which is math. Figure out how much water is still in there. So got my 100. Sliding over my next graduated cylinder. And we're just going to let it empty, allow gravity to take its course. So what I'm going to do is I'm going to empty these beads. We're going to do the math. I'm going to put it all here for you. And then we are going to repeat the whole process using 300 milliliters of 7 millimeter beads. And then repeat using 4 millimeter beads, 300 milliliters of the 4 millimeter beads. Okay, I'll be back with the data. Okay, so I know you guys read the procedure, and this is what we already talked about, filling up the plastic tube with 300 milliliter of beads and allowing the water to flow through. I talked about you have to do a little bit of math. So what we're going to do is I have done the 12 millimeter beads, all the data, 7 millimeter beads, all the data. Right now the 4 millimeter beads, data-wise, so you understand what we're actually doing. So the average wetting front time, the amount of time it took the water to travel through the smaller beads, on average was 3.5 seconds. So to do the reciprocal of the travel time, so I'm taking 1 divided by 3.5, comes out to 0.2857142. We're going to round it to nearest hundredth. So I'm looking at the 5. 5 is going to make that 8 and 9, so 0.29. All right, the water required to fill the pores was 137 milliliters. So doing the percent of pore space, which is right over here for you. So we're looking at total volume of the pores, which is how much water it took to fill, divided by the total volume of the particles, which was 300 milliliters. And then you get times that by 100. So 137 divided by 300 equals All right, multiply that by 100. So I have 45.666 repeating. So I am going to round that to the nearest whole number. So 45.6 is going to make that 46%. Okay, the water that we got back is 125. If I do the math, all right, in order to figure out the water retained, take how much water it actually had, 137 minus 125, which is going to be 12. So the water that's still in the container is 12 milliliters. All right, so if it was a perfect world, your porosity, your percent pore space on row 4 should all be the same. So 50%, 47%, 46%, they're relatively close. Here's the biggest problem. The smaller beads fit together tighter and nicer in the container than the larger ones. So it's going to be off a little. But here's your data. Your permeability is what we expect. The larger particles have a larger pore space, so it should go through quicker. So it took less time. The smaller the particle size, the smaller the particle pore space, so it takes the water a little longer to get through. So the wetting front time was longer, so the permeability had a lower value. High permeability flows through quick, so permeability is 2. Small particles take longer, so it have a lower permeability. All right, do your data, write it up, answer your questions.